Hi, I am Axel.
And I'm Jelly. And in this video, we're gonna be solving some volume integral sample problems. But before that, let's have some little knowledge.
We all know that mass is equal to density times the volume. Now consider a box. Supposedly its density is f of x, y, z. To find out the triple integral, or its volume integral, we'll divide this box into small cubes. Now, the volume of this particular cube will be, or the change of volume, is equal to change of x, interchange of y, interchange of z. This particular cube is present at I, j, k. Therefore at this point, its density will be f of x I j k y I j k z I j k. And now, that we have the volume, and the density, we get the mass of this particular cube. But then, we are supposed to find out the mass of each cube and sum all their masses. By summing up all its masses we'll get the total mass. And total mass will give us the total volume integral.
It was stated that, consider a closed surface in space enclosing volume V. Then, triple integration over V of a dV, then triple integration of a dx dy dz. This is the formula for volume integration. Now let's try to solve an examples.
First example. Evaluate the given triple integral with outer integral limits of 0 to 1. Middle is 0 to x, and 0 to 1 plus x plus y, where f of x y z is equal to 1. Now let's substitute the given. Now we can directly integrate. Let's integrate it with respect to z. Let's substitute the limits. Now, let's find the integration with respect to y. Let's substitute the limits. Finally, let's integrate with respect to x. And we get by substituting the limits we can get and we finally get the volume integral, which is 1.
For our last example, evaluate the triple integral of 2x plus y dv, where V is closed region bounded by the cylinder. Z is equal to 4 minus x squared and the plane x equals 0, y equals 0 and z equals 0. First let's identify the limits of the bounded region. We already have the given values for y limits. For the outer integral limits, we already have the value for lower limit of x, which is 0. And to find the upper limits, we set the value of z to 0 to find the value of x. Then x must be equal to 2. And for our middle limits, we have the values of y, which is 0 to 2. And lastly, for z limits, we have 0 to 4 minus x squared dz dy dx. Now we can finally integrate. Let's first integrate with respect to z. Let's evaluate with limits of integration. Now let's substitute the limits. Next let's integrate with respect to y. Let's apply the given limits. So now we have. And finally, let's integrate with respect to x. And by applying the limits, we get the final answer, which is 80/3 or approximately equal to 26.67.
We thank you for watching our video. We hope that you understand the concept.
Don't forget to wash your hands and stay at home. Peace out.